All right. Welcome, everyone, to Chapter 9. Chapter 9 is my favorite chapter out of the entire class, so I hope you enjoy it as well. It's going to be essentially trig identities and trig equations. All right, so the good news is, well, let's start with the bad news. The bad news is there's like 50 identities you're going to have to use. That's an exaggeration. Maybe like 20 identities that you're going to have to use. But the good news is that I will give them to you for quizzes and exams, okay? So on quizzes and exams, I'm just going to give you a giant sheet of all the identities you can use, and then you still have to know how to use them, so it's kind of tricky. Tricky section, make sure to do the homework. And if you feel nervous after the homework, if you feel like, I don't really know how to do this, just do the odds as well. The odds have the advantage of having the answers in the back of the book as well, so you can check your answers, all right? So here we go. We're going to start with just some rules of thumb, kind of teach you how to approach these. Because one of the interesting thing about these problems is that there's a bunch of different ways to do them. And you never really know which one's the right way, or there are multiple right ways until you just do it, okay? So start with the messier side. This is not going to make that much sense until we actually look at some examples, but we're getting the rules first. All right, we have two rules, two thumbs. Coincidence? Yes, it's a coincidence. All right, and then a good rule of thumb is to put into sines and cosines. All right, and as we do more of these, we're going to develop some more rules of thumb. We're going to figure out, hey, this is a pattern. Hey, this is kind of what else that we can do. And sometimes it's helpful if we do this strategy. And you can add those to the list. But for now, these two are really going to get you where you want to be. All right. So the trig identities. Ooh, I did not think this through. The trig identities you're going to have are essentially most of the ones in 9.1. Most of the identities in 9.1 are identities that we've talked about before. Reciprocal identities, Pythagorean identity, stuff like that. There's only a couple new ones and maybe a few different ways of looking at the old ones that might be worth looking at over here. So here's the sheet right here that I'm going to give you. Oops, that's the wrong button. Oops, that's the wrong button. Here's the sheet that I'm going to give you for quizzes and exams. We're going to be covering the first five today. This stuff right here, the first five are 9.1. Reciprocal identities, we know this. This is just the definitions of the reciprocal functions, cosecant, cotangent, and secant. All right. Pythagorean identities, we briefly talked about these. These are going to be the most new for most of you. All right. And then quotient identities, we've already talked about that. Cofunction identities, we talked about that just a little bit. Parity identities are just what functions are even and what functions are odd. And then we'll talk about these other ones in future sections in Chapter 9. All right, so we're going to be using these 5 groups. And again, there's a lot of them, but you don't have to memorize them, which is nice. So here we go. Example 1. Verify. Part A, I want you to verify that the tangent of theta times the cosine of theta is equal to the sine of theta. All right? And again, tangent of theta, this is a function, this is a value. Tangent takes in an angle and spits out a ratio. So we're going to have two ratios multiplied by each other is going to equal this ratio, the same triangle. And so we just pull out our identity sheet, see what's going on. But even before we pull out the identity sheet, let's go back to our rules of thumb. Start with the messier side. Well, which one's the messier side? The left-hand side. So we're going to start with the left-hand side. So this is an abbreviation that I like to use. The left-hand side is where we're starting, LHS. And that's the tangent of theta times the cosine of theta. And now rule of our second thumb is we want to put everything in sines and cosines. So if you're pretty good, if you're caught up, if you know where you're at right now and have a pretty good grasp of trig, you know exactly how to do that. But if you're not, let's browse the identities. Specifically, we're going to look for this one. Ooh, it's not highlighted what I wanted to highlight. Tangent of an angle is the sine of the angle divided by the cosine of that angle. So tangent is sine of theta divided by cosine of theta, and we're still being multiplied by cosine of theta over here. Well, we can think about this as cosine over 1. We have a cosine on top, cosine on the bottom, they cancel, and we're just left with sine of theta, which is great, because that's exactly what we wanted to be left with. Right? That's our right-hand side. So look at this string of logic. We started with the left-hand side, we simplified it, and we showed that it's equal to the right-hand side. And there we go. That's all there is to it. The difficulty in this section becomes when it's more complicated and you're not exactly sure what to do. So let's do another one. Cosecant theta, cosine theta, tangent theta equals 1. Again, we're going to start with the harder side. And really, a lot of these don't have any question of what side is messier. But if you don't know which side's messier, you can start with the left-hand side, simplify it down a little bit. And then you can go to the right-hand side, simplify it down a little bit. Sometimes you can work from both ends until eventually, hopefully, they meet in the middle. But most of these are going to be obvious which one counts as messier, right? So over here, the left-hand side is definitely messier. Put everything in sines and cosines. So remember, cosecant's a reciprocal function. It's just 1 over sine of theta. Cosine, let's keep that how it is. And again, just like before, we're going to write it as cosine divided by 1. Yeah, most people really are not a big fan of this chapter, identities, but I love it. It's like solving puzzles. We know where we're going. We just don't know how to get there. We try a bunch of pieces until one of them works. And again, tangent, put it in terms of sines and cosines, it's sine over cosine. And a lot of times, not all the times, but like at least half the time, if you get things in sines and cosines, it becomes very obvious what to do next. Because look, we got a cosine on top, cosine on bottom, goodbye. Sine on top, sine on bottom, goodbye. What are we left with? Just 1. That was easy. That's our right-hand side. We're done. Okay? So you might be saying, ugh, boring. Wake me up when this stuff gets good. Well, wake up. We're going to get some harder problems. All right, part C. Let's look at the 1 plus sine of theta. Sorry, x now. 1 plus sine of x times 1 plus sine of negative x equals cosine squared of x. All right, so right off the bat, we have a negative inside the sign. That's no good. Let's see if there's something we can do about that. Reciprocal identities, no negatives on the inside, no negatives on the inside, no negatives on the inside. Kind of, there's a minus sign here, but we just have a negative. There's no minus sign. Oh, yes, right here. Parity identities. Sine is odd. Sine's an odd function, so the negative can come out in front. Let's use that. All right, so the left-hand side is going to be 1 plus sine x. We'll leave that as it is. And this negative is going to come out in front and have 1 minus sine x right here. All right, and at this point, it's not as obvious what to do, but we need to simplify. Okay, there's only a couple of ways that we can simplify this. And the idea is that we are going to simplify by foiling. And technically, you don't have to FOIL here, but that's going to be kind of our best bet, all right? Because if we FOIL here, this is a special formula. This is a difference of squares formula. So if you wanted to, you could FOIL it out the really long way, first, outer, inner, last. Or you could use a shortcut and say this is the first thing squared minus the second thing squared. And as a reminder, right, that sine squared of x is just shorthand for sine of x squared. Okay, these are the same things. That'll be useful later. And so again, we don't have to, 1 squared is just 1, so let's forget about that real quick. So we have 1 minus sine squared. We want cosine squared. So again, we look at our sheet. This one's going to be very common. You may not have seen this yet. We look at our sheet and we try to relate sine squared to cosine squared. So there's no squareds here. There's squareds here. No squareds, no squareds, no squareds. So all 5 of the 9.1, this is the only thing that has squares. So we're going to have to use something here. And there's 2 ways of thinking about it. This is the one that relates sine squared and cosine squared. And specifically, if we write that down, right, we have the identity that sine squared of x plus cosine squared of x equals 1. And something that's very, very common is to rearrange the terms in this. First off, if you wanted to, you could say 1 is equal to sine squared plus cosine squared. Let's just plug that in. But as you get more advanced and get more comfortable with this, you're okay to rearrange this identity right here. Let's subtract sine squared of x from both sides. You get cosine squared of x equal to 1 minus sine squared of x. And that's exactly what we have. So rearranging the Pythagorean identities especially is going to be a very useful trick for you to be able to do. These 3 right here, sometimes just move, you're going to want to move one of these over to the other side depending on your situation. So this is just cosine squared by the Pythagorean theorem, cosine squared of x, which that's exactly what we wanted it to be. We done. All right, so that's kind of the logic on this. And as the problems are going to get more and more complicated, we're going to get more and more skilled at dealing with them. So let's just do more and more. All right, and feel free to stop me if you have any questions. Over here, cotangent of theta. Ooh, no, let's skip that one. Oh, let's do it later. Secant squared of theta. This one's good. This one's good. This is where we really start testing your algebra skills. All right, if your algebra is not really strong, this section is going to be way harder than it needs to be, because a lot of the times it's not the trigonometry in this section that's difficult, it's the algebra. So again, left-hand side looks messier, so let's start with that. Secant squared of theta. We want to write everything in sines and cosines. That's our rule of thumb. So if we do that, we get 1 over cosine squared of theta minus 1. This is our numerator. Oh no, 1 over cosine squared is our denominator. We have a complex fraction. And we had 2 ways of dealing with complex fractions. If you remember back to your Algebra 2 class, how we deal with complex fractions, fractions within fractions. One is to write it as division, and then you have to get this as the same fraction, find the least common denominator, and then multiply by the reciprocal. But we have a shortcut. If we multiply the top and the bottom of the fraction by the LCD of the little guys, then all the fractions go away except for the big one, and we get really nice stuff. So we multiply the top by cosine squared of theta and the bottom by cosine squared of theta. So on the top, this little guy distributes. On the bottom, it just multiplies and cancels out. Well, this is really nice, because on the top, we get cosine squared of theta. I'm going to write this step out real quick, just in case you're curious. Oftentimes in the future, I won't do it. All right, so this is what happens when we just strictly multiply it out. We get some really, really nice cancellation. Cosine squared over cosine squared, careful, it doesn't cancel to 0. This cancels to 1. Same on the bottom, cancels to 1. So what we're left with on the top is just a 1 minus cosine squared of theta, and on the bottom is just a 1. We don't need to write the divided by 1. And wait a minute, this looks kind of familiar. Earlier we said 1 minus sine squared of theta is cosine squared of theta. We used x's. Here we have 1 minus cosine squared of theta. Could we do the same thing? Let's look at the Pythagorean identity again. Right? Well, 1 minus cosine squared, let's subtract cosine squared from both sides. That gives us this. Rearrange Pythagorean identity strikes again. Aha! This is exactly sine squared of theta, which is hopefully what we wanted to prove. Look back up towards, x, theta. It's a theta. You saw nothing. Yeah, we did want to show that it was sine squared of theta. Great. Ta-da! So you're going to be rearranging the Pythagorean identity a lot. 1 minus cosine squared, 1 minus sine squared. Just make sure that you are correctly rearranging the identity. Write it down, move things around. Because some things, bad news, some things are going to look like a Pythagorean identity and not be one. That's going to come in two examples, not the next one, but the one after that. So make sure to write it out and be careful. Don't be baited. Don't be tricked. I will try to not intentionally trick you, but we'll see how it goes. Oh dear, what letter are we on? E. There's only 2 more examples today. All right, kind of a short day, which is nice because this stuff is great, good stuff. And really, you have to learn it by doing. It's like if you watch someone solve a Rubik's Cube, right? You're not going to just figure out how to solve a Rubik's Cube by watching someone. You can maybe learn a little bit if they're trying to teach you, but you just kind of have to do it yourself. Same with this. All right. So probably get started on these. We'll finish the section tomorrow, though. Let's do another good one, another juicy one. Sine squared of negative theta minus cosine squared of negative theta over sine of negative theta minus cosine of negative theta equals cosine of theta minus the sine of theta. So this one's a real quality thing. All right. And really, you have to be very, very careful on this one too. Obviously, left-hand side's messier. Let's start with the left-hand side. We definitely want to start with the left-hand side to make it look like the right, as opposed to starting with the right to make it look like the left. I would have no idea how to do that. All right. So something we really have to look at, again, we have those negatives. We're going to be using the parity identities, evens and odds. But the squared kind of throws us for a loop. You might think, oh, it's sine. So negative just comes out in front. But be very careful because the parity identities, let's look at them. They only apply to sine, not to sine squared. So let's go after the sine and make sure that the negative comes out like we might expect. So let's just go off to the side. Let's look at sine squared of negative theta. Remember that this is shorthand. This is shorthand for sine of negative theta, squared. So we can use the parity identity on the inside to say sine is an odd function, so the negative comes out in front. Wait a minute. But now we're squaring a negative theta. Squaring a negative makes it positive. So it's actually still positive sine squared of theta. And cosine's an even function, so the negative goes away anyway. Cosine, you really don't have a big problem. So sine squared of negative theta, we just said that was sine squared of positive theta, using the definition of sine squared and the parity identity. Cosine squared of negative theta is just cosine squared of positive theta. So this negative goes away, but the subtraction still stands. In our denominator, it's odd, no squared, negative just comes out in front. Negative sine of theta. This one, cosine's even, negative goes away. You get minus cosine of positive theta. And again, you might think, oh, we got sine over sine, that cancels. Cosine over cosine, no. Remember your algebra. You can't cancel the numerator and denominator unless things are factored. All right? So we need to factor. No cancellation without factoring. And you might also think, hey, this numerator looks familiar. Is this a Pythagorean identity? No. No, it is not. Okay. There is no way to rearrange this equation to be useful for sine squared minus cosine squared. Although in the future, it actually is we could use the double angle formula, but we don't want to. Definitely don't want to use double angle. And that's not part of 9.1. By the way, what I would recommend for you at home is when you're doing the homework, print out this sheet. I will upload it to Canvas as soon as this lecture is finished. Download this sheet, print this sheet, and then write next to this 9.1, 9.1, 9.1, 9.1, 9.1. So when you're doing the 9.1 homework, you know to use these 5. All right. And then 9.2 is only this one. And so you can kind of have a good idea of what things are and what sections go to where. Okay. And if you want to use your own personal trig identity sheet with some scratch work on it, you can for quizzes and exams. You don't have to use the one I provide. All right. So here we go. So we need to factor the top. And again, maybe we need to brush up on our algebra. We have something squared minus something else squared. How does that factor? Let's look. It's a lot of times easier to look at factoring when you have x's and y's. All right. 9.2 for a lot of people is going to be way worse than 9.1, even though it's only that one little thing of identities. It's really a special section. They're all kind of special. This whole chapter is a good time. All right. So this is the difference of squares. Something squared minus something else squared. It's going to factor x minus y, x plus y. All right. So in this case, x is the sine of theta. So we have the sine of theta minus the cosine of theta times the sine of theta plus cosine of theta. And before I even write the denominator, I don't want to write the denominator like it is because it looks different. I want cancellation, but this is not in the numerator. So let's rewrite this. We can factor out a negative from the denominator, from both of them. So factor it out and becomes positive sine theta and positive cosine theta. And every time you factor, it's a good idea to just check by distributing or foiling that we factored correctly. Difference of squares. The top is going to equal sine squared minus cosine squared. That's what we had. The bottom, if we distributed the negative, we get negative sine minus cosine. That's what we wanted. It's a good way to check and good idea to check that you're factoring correctly. And now, sine theta plus cosine theta, we have one of these up here. Boom, boom. We're left with sine theta minus cosine theta divided by -1. Again, we can think of this as a -1. So dividing by -1 is the same as multiplying by -1. So it just becomes negative sine of theta plus cosine of theta. Again, you distribute that -1 in to both of these. And it looks similar. Is it the same? Yes. Let's just rearrange the order. We have a negative sine and a positive cosine. Well, let's write the positive cosine first, the negative sine second. And that is exactly what we wanted. We did it. And this is one of the worst ones in the whole section. So if this one feels easy, then you're in a good spot. If this one feels not easy, well, don't worry. We'll have more examples today and tomorrow. So we have one final example to kind of cool you off. We just did E. E for excellent. Now F is going to be for boring. F is going to put you to sleep. Cotangent of theta divided by the cosecant of theta equals the cosine of theta. So again, just like always, this book is kind of boring. I steal my example from the book, so I guess I'm boring too. Left-hand side's more complicated. So let's start with the left-hand side. Cotangent, cosecant, we don't want to work with those. They're garbage to work with. What did our rule of thumb say? It was on a different piece of paper. What did our rule of thumb say? Put it in terms of sines and cosines. So again, cotangent is sine of theta divided by cosine of theta. Cosecant is 1 divided by cosine of theta. And now you may be tempted to cancel here the cosines, and you can cancel here. But be very careful when canceling complex fractions. I would recommend not to cancel because sometimes you'll cancel when you actually can't. There are two ways of dealing with complex fractions. The top multiplied by the reciprocal of the bottom, or like before, and like we're going to use again, let's multiply the top and the bottom by the LCD, which in this case is cosine of theta. So, okay, it's going to cancel with that in the top. It's going to cancel like that in the bottom. And we're left with sine of theta divided by 1. Oh dear. Oh dear, I made a grievous error. Anyone see my grievous error? Cotangent is not sine over cosine. Cosecant's not 1 over cosine. We did the wrong first step. Just testing all of you. Just testing all of you, okay? Remember, cotangent is a reciprocal of tangent, so it's going to be cosine of theta divided by sine of theta. Cosecant is a reciprocal of sine, 1 over sine of theta. There we go. So notice this teaching opportunity we have right here. It cancels the sine theta, and immediately I said, sine theta? We were supposed to get cosine theta. Good indicator that sometimes you're going to make a mistake. And you can easily say, aha, I made a mistake, and go back and try something else. Haha. All right, but we do the same thing. Multiply by the LCD, sine theta over sine theta. It's going to cancel. We're left with cosine theta divided by 1, which is just cosine of theta. And we have a check mark, we have a happy face, and an even bigger happy face, because we got it right. All right, that's exactly what we wanted. More of this tomorrow. So this section's homework, this week's homework is only going to be 9.1. 9.2 will be due next week. Or 9.2 will be done next week, due the week after, and probably also include 9.3. This is the best part of the class. Hope you're enjoying as much as I am. We got 4 more sections of this, and one more class of this video, of this section. One more video of this section. Hope you enjoyed it. Have a good day.